So what I want you all to do is take a look at your lab handout for the modern Galileo experiment, accelerated motion, and I want to talk about how you're going to go about conducting this lab. So if you take a look at the rubric, there's only a few things that you need. First of all, you do have to have a printout of the velocity time graph and the position time graph that you were able to save and maybe email to your group members over the last couple of days. For those of you who are not in class the day that we conducted this lab, all I'm going to ask you to do is photocopy the printout from somebody else in the class, and if you can get the data table from them as well, if you can just take a look at their data and record their data onto your handout as well, that's more than you're more than welcome to do so. That's fine with me. Okay, but let's take a look at the first page of this lab. One thing I want you guys to all do is, of course, read this part of the read this part of the lab. These three paragraphs will help you, or I hope will help you, answer question number 2 of your analysis question. Okay, so please read this over carefully. I'm going to skip on over now to the bottom of this handout. Let's see what we have down here. Okay, if you take a look, this is where the procedure begins. It's probably a good idea for those of you who are not here on the day of the lab to at least go over the procedure so that you have an idea of what we did to sort of come up with our data. So if I turn the page over now to the data table, one of the things that you were able to do was come up with a whole bunch of data points. Now, depending on the group that you were in, I think I recall one of the groups had 10 data points, which means that you were able to come up with something for time speed for 10 different points. Okay. However, some groups only had 5, 6, or maybe even 7 data points as well. So let's pretend that you were one of the groups that only had 7 data points for time and speed. What you're going to do is, if you take a look at the velocity time graph that you were able to obtain, you should have been able to come up with the slope of the VT graph by using one of those functions. So by taking the slope of the VT graph that you have, you should be able to fill in this part over here. Now the question is, what about this average acceleration? How do you find the average acceleration? Well, if you take a look at the analysis question that you have, I think it's question number 4. The analysis question number 4 says that what you have to do is take a look at your first data point and your very last data point. And since you know that the average acceleration is equal to v2 minus v1 divided by t2 minus t1, what you're basically doing is you're taking this value for v2 minus this value for v1 and dividing it by this value for t2 minus this value for t1, and once you work out that average acceleration, that's what you're going to record into this box down here. Okay, now ideally it'd be nice if you take a look at these two numbers in here. They should be fairly close to each other, but keep in mind during a lab things sometimes go wrong, so they may not be exactly the same. They may be off by hopefully just a little bit. Okay, now if you take a look further down at this data table, we have a couple of other things you have to fill out. Let's take a look at this section over here. So now what you're going to do is you're going to take a look at the DT graph that you obtained. Now on that DT graph, take a look at your initial position and your final position. So these again are numbers that you should have been able to obtain from the lab itself. So once again, feel free to copy these values from your group members. Whatever your final position was, subtract your initial position should give you your total distance traveled. What I want you guys to do now is you're going to take this total distance traveled and you're going to use this as your delta D measured. Okay, and you're going to use this a little bit later on in question number 5. Now, from your velocity time graph, what you're going to do now is you're going to find the area under the graph. So once again, for those people who are not here for the lab, you can't really do this lab, but you can, of course, you're allowed to copy this value from your group members. So if you take a look at your area under the line for the VT graph, this is going to become your delta D accepted. Okay? Now, if you take a look at these two values, Of course, you're going to have to come up with a percentage error calculation using these two. So let's take a look at our analysis questions. So if you take a look at these analysis questions, you should be able to see 1, 2, 4, 5, and 6. Of course, I deleted number 3. You don't have to do that one, obviously. So what I want you to do is look at number 1, 2, 4, 5, and 6. Question number 1. Calculate the change in speed between each of the points in your data table above. Enter these values in the right column of the data table. So if you take a look at your speed for data point number 2 and your speed for your data point number 1, if you subtract those two, that should give you your change in speed. And that value is what I want you to record on the right-hand column. But then if you take a look at data point number 3 and data point number 2, if you calculate the difference between those two values, that should give you your next change in speed. All right, so if you take a look at your far right-hand column, if you look at all those different changes in speeds, take a look at what those differences are. Are they the same? Are they fairly close? Or are they wildly different from each other? So take a look at those data. Take a look at the data that you obtained, and you're going to need that to help you answer question number 2. So using all those values of changes in speed, how do they support or refute Galileo's definition of uniform acceleration based on what you read in those first 3 paragraphs? Okay. So question number 1 shouldn't be a problem. Number 2, you do have to think a little bit about that. Question number 3 says, calculate the average acceleration using this equation over here. Now, we've already done this, and we recorded that in your data table where it says average acceleration. So this should be a fairly easy mark to come up with, but one of the things I want you to do, a lot of students forget to do this, is show all work. Okay, so not only show all your work, but it also goes on to say, how does this compare to the value of the slope obtained from the velocity time graph? Are they similar? Are they completely different? Are they close? And of course, later on, you're going to have to explain if they were different from each other, why they were different. Question number 5. So now question number 5, this is the one that we talked about in class. I'm going to rewrite this equation down here. So we got percent error is equal to the absolute value of delta D measured minus delta D accepted. All of this divided by delta D accepted, okay, multiplied by 100%. Now obviously I did leave this part out in the original equation, so please can you guys do me a favor and add this times 100% over there as well. Okay, so just add this times 100% over there. Okay, so if you take a look at your data table again, you should have been able to come up with delta D measured and delta D accepted. Let's say in our particular lab we came up with the following numbers. Let's just say that for delta D measured I ended up with 0.075 meters, or 75. Sorry, let me rewrite that. So let's just say I came up with 0.75 meters or 75 centimeters as my delta D measured. And for my delta D accepted, let's just say 82 centimeters, so minus 0.82 meters. All of that divided by my delta D accepted again, 0.82 meters. Absolute value, all that multiplied by 100%. Okay, so now based on the values that I obtained, let's just see if we can calculate what our percentage error is. If I take a look at the numerator side, I end up with an answer of negative 0.07 meters divided by 0.82 meters times 100%. And if I work this all out, let's just do a quick calculation, 0.07 divided by 0.82. I end up with the answer of 0.09, and I leave it as a positive value because what this absolute value sign does is it says, we don't care about what that sign is going to be, whether it's positive or negative. We only care about the magnitude, which in this case is just 0.09. Take that multiplied by 100%, and that gives you a final percentage error of 9%. Okay, and that's how you would go about calculating your percentage error. Now, naturally, for you guys, you're not going to use these values. You're going to use the values that you obtained from your data table. So if I go back up to question number 6 now, sorry, let's just check off number 5, so that shouldn't be a problem. Number 6, what are some possible sources of error that may have led to discrepancies in your data? All you have to do now is come up with 2 or 3 different reasons as to why your values for delta D measured or delta D accepted were not quite the same. Also tell me why maybe your acceleration that you obtained from the slope of the velocity time graph compared to your average acceleration from this calculation, why they were not the same as well. So talk about some of the different sources of error that may have led to these discrepancies. And once you've completed that, you're finished your lab. So make sure you go over the rubric very carefully, and please complete this for Monday. Keep in mind this is not a formal lab, so it doesn't have to be on you don't have to do a purpose analysis. You don't have to do a purpose, hypothesis, conclusion, nothing like that. Just complete whatever you see on that rubric. If you have any questions, please post to Edmodo or talk to your friends. Thank you very much.